Historically, virtualization meant creating a system within a system, partitioning hardware into multiple virtual machines. To get an idea of the most basic of virtualization ideas, think of the hard drive on your computer and how it can be partitioned into multiple hard drives. All right, take that concept and think of it being applied across the network to multiple systems, but the same general idea of just segmenting things so that a computer system understands them in a slightly different way. You could also simulate one operating system or application within another system. Today, it's starting to mean merging analogous system resources into carefully designed resource groups, things that can be called in different ways, including as full services, and allowing these to be ramped up or down as dictated by whatever your business needs are at that particular time. Well, how's it built? A virtual system doesn't really need to be constructed as a blade system or a central server farm. That is the solution that most vendors will come through and pitch to you. We can do this cheaply, we can put it on a blade system, and frankly, it's not a bad solution at all. But there is a certain cost associated with migrating that way, and we try to stress to people that virtualization can be done over an existing network using your existing machines. It's just a matter of kind of dipping your toe in the water and starting to get used to virtualization using the stuff that you already have as you're starting to migrate to more of a service-oriented architecture. An application running in a virtual environment must be constructed to interact with a specific registry of files and components. So that's really the first piece of the system that you would set up in order to start building your virtualized environment around it. When it's designed well, the environment fundamentally operates as a separate layer between the application and the server operating system. Now, there's already a model that you can think of, again, for that. Think of the Java applications that you interact with on your computer all the time. Think of, if you ever do any sort of online stock trading, you go to your online stock system, you want to read the ticker, you want to see what's happening with the charts, a Java applet loads. That Java applet, in turn, pulls data from multiple different systems. So just gives you an idea of some of the things that can be done in a virtualized environment. Again, that just being a little model to consider. So why should you do it? Well, right now, government offices are being pushed heavily towards system consolidation. They have multiple systems doing the same thing across an agency in different departments. Traditionally, go back a few years, multiple departments had their own HR systems, their own transaction processing systems for finances, et cetera, and there's a lot of pressure on them to start consolidating those systems. In fact, there's pressure, too, to start looking at the so-called centers of excellence. If I'm a department that's been running its own HR system for a long time and that system needs an upgrade, is I put my budget together and say, hey, I would like more funding to upgrade this system. The Office of Management and Budget is looking at each one of these proposed projects right now and saying, I don't know if we need to dedicate money to this right now, because what you're proposing can probably be done cheaper if you were to simply outsource what you're doing to one of the government's own centers of excellence for things like financial management, HR systems, and there's several centers of excellence in development right now. So consolidation is important, but it's really kind of just the starting point, because as a system grows, the economy of scale is such that virtualization starts becoming more attractive to the really large systems that are dealing with multiple older systems where they're trying to pull in the business and the processing power from them. It's not really just about reducing numbers of machines and software licenses. It's about developing larger solutions that move towards standardizing an organization's architecture and allowing it to be able to bring in low-cost machines, blade systems, things like that that will allow the economy of scale to go up, possibly the staffing of a data center to go down. We'll talk about that more in a little bit. System managers face a challenge, though, managing their current systems while trying to migrate toward the eventual component standardization that is one of the goals of a good virtualized environment. Government, interestingly enough, can be a good proving ground for virtualization. As managers work to consolidate their applications across multiple departments, multiple agencies, a virtualized environment can employ grid scheduling, advanced threading techniques. It allows processors to be redirected at any time to different resources. And this allows for a type of business continuity in government that can be difficult to achieve. Resources increasingly are hosted on groups of shared servers and sometimes mirrored across to other servers and backup data centers, et cetera. Allows data and services to be called from multiple other machines or systems, and allows, obviously for easier threading, resource sharing, et cetera. But I kind of will, flash the security sign over that too. When you have this type of virtualized environment, in theory, it can be picked up and moved to a different data center when needed in times of natural disasters or terrorist attacks. All right, but what are the main drivers outside of that? Well, cost savings, ease of administration, reduced overhead, improved security. Government adaptation of virtualized environments can be driven by IT systems integrators tasked by the agencies to help them reduce their machine overhead, numbers of software licenses. So the big systems integrators are helping to push this into the agencies. I see that more than I see the agencies going and talking to the systems integrators saying, hey, this is what we have to do. I want to go this direction immediately. It's being built by driven by the builders of high-end servers, systems, big blade solutions. Together, they support the multi-threaded processing, embedded special technologies to enable that service aggregation. It gives them a logical view, but again, this goes back to, should your agency move in that direction or should it not? And it really comes down to whether the virtualized environment is going to give you a return on your investment or not.